ഇതെന്താ ഈ സ്ക്രീൻ വെയിറ്റ് വരും. എത്രയായി? 25, 50 ആകുമ്പോൾ നമുക്ക് സ്റ്റാർട്ട് ചെയ്യും. സ്റ്റാർട്ട് ചെയ്യാം. നമുക്ക് വെറുതെ സ്റ്റാർട്ട് ചെയ്യാം. 25 എത്ര പേര്? 50 പേരായില്ലേ? ഓൺ ചെയ്യണം മൈക്ക്. ക്യാമറ മൈക്കും ക്യാമറ ഓൺ ചെയ്യും.
A very warm good morning to one and all. It's my pleasure to welcome the resource person of the day, Dr. Jeeva, respected principal and teachers, to the webinar on Introduction to Data Science using Python. Before we start our webinar, I request each one of you to have a 1-minute silent prayer. Thank you. So, taking our webinar further, I, on behalf of everyone present here, heartily welcome the resource person, Dr. Jeeva, who is presently working as an associate professor in the Department of Computer Applications at BPC College, Piravoom. She has been in higher education since 2000. Apart from this, she is a well-known trainer in Python, data science, machine learning, and R programming. Now, I hereby hand over the session to Sanam S, HOD of Computer Application SRBS GUJARATI College.
Thank you, Khushbu, and I am here for the welcome speech. Good morning, everyone. First of all, I would like to welcome our resource person, Dr. Jeeva. She is presently working as an associate professor in the Department of Computer Applications, BPC College, Piravoom. She is a well-known trainer in Python, data science, and machine learning. She has been authored 14 books and edited 3, which has been published by international publishers. She has designed and delivered course content for TCS for their massive open online course. She is a recipient of ACMW scholarship provided by Association for Computing Machinery, New York. And next, I would like to welcome Sri Kishore Shanji Kuruva, President of Sri Cochin Gujarati Mahajan, Professor R.V. Kilikkar, our educational advisor, Sri Bharat Khona, Manager SRBS Gujarati College, our beloved principal Dr. K. Prasanna, who gave us motivation for conducting such a webinar, and all my dear colleagues and other participants of this webinar. Thank you.
Thank you, ma'am. Then I would like to invite our principal, Dr. K. Prasanna ma'am, to officially inaugurate this webinar.
Distinguished guest Dr. Jeeva Jose, respected President of Gujarati Mahajan, Cochin Gujarati Mahajan, respected Manager and Educational Advisor and all the trustee members of Cochin Gujarati Mahajan, and also the Educational Advisor to Cochin Gujarati Mahajan, and all the participants including research scholars, teachers, members of different institutions, companies, and all my students and friends, or rather, embodiments of divine love. I feel really happy to talk to you today because this is a subject of relevance today. All people are talking about machine learning and artificial intelligence nowadays. At this point of time, I remember one of the anecdotes in my early childhood days when I was studying at a primary school in a village in Palkar district, when a teacher of mine brought a tape recorder and recorded my song, and I was wonderstruck hearing my voice from the tape recorder. Gone are those days. Nowadays, even children are talking about robotics, coding, etc. See, as far as I am concerned with, I know a little bit about computers only. See, data analytics, data science, data mining, and big data are not the same. They are variants, I presume. And data science actually uses data programming, modeling, etc., and also uses algorithms to explain system operations. Data science is a subject which is of great relevance today because data scientists are in demand, especially in the health industry, used for health diagnostics as well as diagnostic research as well as MRI scanning and also X-ray reading using computers. There was a time when people looked upon computers sarcastically and criticized it, thinking that it will result in technological unemployment. Gone are those days. Data scientists are in great demand nowadays. And huge data analysis also, and the experience in data research is also required for data scientists. And I have come to understand that Python is also a programming language which is used greatly in data science research. So it is very important to discuss about Python and data science nowadays. Now coming to brass tracks, let me do my duty. I feel very happy to inaugurate this national webinar and I welcome Dr. Jeeva Jose to this function. Let this function be a great success and I declare this webinar as inaugurated. Well, once again welcoming all the participants and let this be a great success. Thank you.
Thank you, Principal Ma'am. Now I invite our resource person, Dr. Jeeva Jose, ma'am, for the content delivery.
Good morning, my dear participants. I hope I am audible properly. Can anyone respond? Is it audible?
Yes, ma'am.
Yes. Okay. So, first and foremost, let me take this opportunity to thank the management, principal, and all the members on the faculty of SRBS Gujarati College for inviting me as a resource person. And special appreciation and congratulations to the coordinators for the efforts they have taken. And I know Sanam and Rishmi, the coordinators of this program, for last or 12, 10 or 12 years. So that is why I should say I'm here today. So before getting into my talk, I would like to tell you one thing. Data science is a very vast subject, and the time for me is only 1 hour. So I will try my level best to give at least some drops of water from that.
കേൾക്കുന്നുണ്ട്, കുറവാന്നേ ഉള്ളൂ എന്ന് തോന്നുന്നു അല്ലേ? കേൾക്കുന്നില്ല?
ഞാൻ മീറ്റിംഗ് ജോയിൻ
ജോയിൻ ചെയ്യാം.
So I think my screen is visible, right?
Sound is very low. Can you type?
Yes, ma'am.
Yeah. So, as the title says, it is about data science, and we use a tool called Python. So, Python is it is a trending programming language nowadays, and or this is the most sought after programming language nowadays. And we can see Python in almost all domains, whether it be academia or research or industry. Python is used extensively. And let us begin with from where the data is generated. As you know, there are a lot of sources for data generation, like data can be generated from social media, it can be generated from sensors like temperature sensors or pressure sensors. Then it can be generated from mobile phones, a lot of images or videos you are taking. It's an example for data. Then global positioning systems, GPS, is generating a lot of data. Then the online shopping markets like Amazon, Flipkart, everything is generating tremendous amount of data. Then coming to World Wide Web, day by day it is growing. Then emails, media streaming, healthcare data, and IoT. IoT stands for Internet of Things. It is also generating huge amount of data, I should say in the order of terabyte, petabyte, zettabyte, or sometimes exabyte. So that is, that amount of data is generated daily. And wherever there is data, we need or there is a requirement for analyzing the data. So that is how this branch of computer science, that is data science, evolved. And when I say data analytics, there are four types of data analytics. So four types means the first one is what happened to the data. And the second type of analytics is why did it happen? And the third one is what will happen to the data? And fourth one is how can we make it happen? So the first one, that is what happened to our data, we call it as descriptive analytics. And why did it happen? Or the reason for happening, we call it as diagnostic analytics. But the industry people are more interested in the predictive analytics and prescriptive analytics, which says what will happen in future and how can we make that happen. The left side of this analytics, that is descriptive analytics and diagnostic analytics, is just like doing a postmortem. Like everything has happened already, and we are trying to figure it out what has happened. May not be that much interesting. And if you look at the right side of this graph, it is predictive analytics and prescriptive analytics, which is really, really important. And as we move on this x-axis, you can see the difficulty of doing this. This analytics is really difficult. Predictive analytics as well as prescriptive analytics is really tough or difficult to manage. Whereas, towards the left side, that is descriptive and diagnostic, is comparatively easy. And if you look at the y-axis, the value goes up. Value goes up means, for predictive analytics and prescriptive analytics, the value is more because, if you could predict what will happen to your company or organization after 10 years, it will be of more value. So that is having more value. And as I said, you can classify data analytics like this, less important and past. So that comes under the category descriptive and diagnostic. And at the same time, the future data, that is predictive and prescriptive, we say that it comes under the category of future, and that is of more importance or more value. And at the same time, it is very, very complex. And there are a lot of data analytics tools are available today. like SAS. I don't know how many of you heard about SAS. Towards the western side, most of them use SAS. Then R. R is a very commonly used statistical software, and this is an open source. Again, SPSS. SPSS is Statistical Package for Social Sciences, but it is a proprietary software. Then Power BI. Power BI comes from Microsoft. Then Tableau, then Python, and even our Excel could do a lot of analytics. So it is up to you to choose which tool you want. Some people prefer proprietary software, but some industries use open source. Some programmers prefer Python, but some statisticians prefer ours. Because each and every software has its own features. So today we will focus on Python only. And some people, you look at this slide, this is a funny one, just to make you understand what is the relation between data science and statistics. So I'm sure you'll be smiling because many times people have a false belief that data science is something new or it's a new branch of science. No, it is not like that. If you pull out the mask of data science, you can see that the real person behind that mask is statistics. So if you know statistics, data science, it's very easy or it is just as easy as plucking a flower. So I should say, if you are very good at statistics, then it will be very easy to master data science. Again, I will show you one more slide to show the relationship between statistics and computer science. So you look at the first picture, that is an elephant and a snake. You imagine that elephant is the statistics because elephant is more powerful here in the sense, in the case of data, as far as data science is concerned, statistics is more important than computer science. So the snake is telling to the elephant that we will work together, and the snake is trying to swallow the elephant. And the snake is asking, telling that, please teach me statistics. And the snake somehow swallowed the elephant. And now it's a dinosaur. See, so now the snake and elephant combine together to form a dinosaur. And you can say that now I am data scientist. But you should realize one thing, one important thing is that inside the snake, it is the elephant, which is the statistics. So that I want to make it very clear to you that data science is not computer science. The majority portion of it comes under statistics. So I think it is clear to you. Can anyone respond at this point? At least for my satisfaction that you could follow this.
Yes, ma'am.
Okay, thank you. So we will see some of the giant companies which are using Python for data analysis. This is only a few, like Facebook, Ford, Google, Microsoft, Thomas Cook, Twitter, Uber. All these companies, it's very familiar to you, and it is using Python for its data analytics. So when I say data science or data analytics, most of the time we will be handling or we will be working with structured data. Structured data and unstructured data, you may be knowing structured data, your DBMS. It's an example for structured data where the data will be arranged in rows and columns. But if you look at the Facebook data, it is different. Like, it may be having some structured things, but at the same time, it will be having images, it will be having videos, it will be having some other application programs. So we need different approach for doing the analysis. So we need to combine this machine learning and AI along with the conventional data science. So here I will be today talking about the structured data for data analytics. And we will move on to the Python part. I should say for me, it is the interesting thing because I am basically a passionate programmer. So I would like to do the coding. Since this is a very short webinar, what I have done here is I have coded it for you and I will just show you the code. So I think you have heard about CSV files. CSV files means it is comma separated values. So I think I will switch to the screen to Python. Okay, so this is the basic Python. Okay, let me share my screen once again. Yeah, this is the basic Python ideally. I have not used any sophisticated idealies. There are a lot of idealies like PyCharm, Spider, etc. But for easy understanding and for a beginner, I have used the basic ideally. So for you, I will show you what is a CSV file. So for example, this is a CSV file. Okay, this is a CSV file in the sense it looks like Excel. Thus, you can take open an Excel file, you can enter some data, and while saving, you can save as, save as. See CSV. Here you can see save as type CSV. So if you choose this option, there are a lot of options here, like a 93 format, 2003 format, likewise. But if you choose the CSV, comma delimited, it will be saved as a CSV file. Or you can also use a notepad to create a CSV file. So what you have to keep in mind is that companies will be storing data in their DBMS, maybe in Oracle, in SQL Server, or whatever it be, or MySQL, whatever it be. You can import data to Excel, or you can import the data as CSV file. So when I say CSV file, it's actually an Excel file with extension .csv. So I think it is clear for you now. Yes or no?
Yes, ma'am.
Yeah. So what we are going to do here is, the first thing what I'm going to do here is we will see how to read from a CSV file and fetch to this Python environment for doing the data analytics. So that is the first step that we need to do. So I will say there are a lot of data structures, built-in data structures, which is very powerful in Python. I'm not going to talk in detail all that, but data frame, it is very, very important. So that is a two-dimensional data structure. It looks like a table. So what I'm going to do here is I'll be reading from the CSV file, and I will fetch to this data frame. So for that, what I'm going to do here is I will open, since I have coded it for you. Yeah, there is this is the file. So it is as simple as that. The thing is that you have to import a third-party module called pandas, because all the data analytics, all the statistical functions reside in this module. Like, if you're a Java programmer, you need to import a lot of files, like applet. If you're working with applet or swing, you'll be importing appropriate files. So appropriate modules. Likewise, here pandas is the third-party module, and this is the alias name used. Alias name used means it is the pet name. Like you'll be having a pet name. For example, your name is Unikrishna Menon. Nobody is going to call you Unikrishna Menon, come here. You'll be calling Uni, please come. So likewise, I have used an alias name here, PD. And this is the function read underscore CSV, and I'll be opening this file. The name of my file here is input.csv, and I'm simply printing this. So it is as simple as that, and I will run the program for you. We will see what it is. See, you can see what I have typed in that CSV file. Earlier, I have shown you a CSV file here. The same thing. What I have done here is I have read it from the Python environment, and I have fetched it to the data frame, and I have displayed it on the screen. So that is what I have done here. So for any data analytics to be done, the first step is you have to fetch the data to this environment. If you're working with Python, you need to fetch it to the data frame, or there is another data structure called a series. So depending on that, depending on your requirement, you have to decide which data structure to choose. Here I have chose this, data frame. So data frame is very, very important. It is very frequently used. And so now you understood how you can read from a CSV file and you can fetch data to this Python environment. And now we will see one important thing, and a very commonly used simple statistical technique, that is called correlation. So you might have learned this correlation in your school classes, from your school classes, maybe in your college. And in everyday life, the statisticians are very frequently using this correlation. So actually, I should say it is the measure or the strength of linear relationship between two quantitative variables, for example, like height and weight. So there are three types of correlation, like positive correlation, negative correlation, and zero correlation. So zero positive correlation means, both variables will be moving in the same direction. Like, for example, I will tell you there is a positive correlation between height and weight, which means as the height increases, the weight also increases. So that we say as positive correlation. In the case of negative correlation, when one increases, the other variable will be decreasing. So in that case, we will say that there is a negative correlation, like you can say as age increases, health decreases. And there will be sometimes no correlation or there will be no relationship. In that case, we will say zero correlation. Like, you can say that there is no relationship between the amount of tea drunk and the level of intelligence. So in that case, you can say that there is zero correlation. So these terms, it is very commonly used, or you may be knowing this: positive correlation, negative correlation, and zero correlation. And for finding the correlation, this Carl Pearson's correlation coefficient is a very commonly used correlation coefficient. And if you're getting the value as 1 of this coefficient, it says that it is having a perfect positive correlation, and that happens only for ideal case. Normally we will not get 1. It will be close to 1, maybe zero point 0.9 or 0.98 or 0.97, something like that. If it is like that, if it is very close to 1, you can say that it is having a positive correlation. But if you are getting exactly 1, you can say that it is having a perfect positive correlation. And same is the case with -1. So if you're getting a perfect -1, you can say that negative correlation. Or if it is close to -1, you can say that it is having a negative correlation. And if you're getting a value 0, then you can reach the assumption that there is no correlation between these two variables. So I think you understood the concept of correlation. If at all you don't know what correlation is, can you have anybody respond? That will be very happy for me.
Yes, ma'am.
Okay, so we will see how to do the correlation in Python, and for that I'll be using a data set. So what I'm going to do here is I will open. Okay. So for that, before you have to understand that you cannot do all the type of data analysis in all the type of data. So that is the first and foremost thing you have to keep it in mind, because if you look at the previous output, I will show you the previous output. See, ID, name, salary, start date, and department. So the thing is that we will be doing correlation on numeric values. If you have numeric values, and you have to identify whether they are having any relevance. Okay. So if you look at this file, input.csv, there is, I should say, ID and salary is numeric, but there is no meaning in finding a correlation between ID and salary. So there comes the knowledge of a statistician, or there comes the importance of the knowledge of statistics. So you should know what all variables are related. Only then you can apply this tool. So I will say Python is at the end. You have to study well the statistics. Only then you can be a good data scientist. So I am taking another data set for showing this correlation. So for that, I will be opening another file called height. Okay. So in this file, I have stored, I have used a very small data set. Whenever I show you this on the screen, you imagine that you'll be working on lakhs and lakhs of records, or hundreds or thousands of records, not on 10 or 5 records. But in order to show it on the screen in a very compact way, I'm using only some 10 or 20 records. So this is my file. I'm having name, height, weight, and marks. I have stored maybe some 10 or 15 fields I may be having, or 10 or 15 columns I may be having here. And I have filtered this in such a way that it contains only name, height, weight, and marks. So can you tell me at this point whether height will be having any correlation? Is there any meaning in doing a correlation between height and marks? Can you say that if height increases, marks increases? Or can you say that if weight decreases, marks decreases? These three are numeric values, but you cannot say like that, right? So that is what I was telling you in the beginning. You have to apply, or some statistics to identify which all variables will be having a relation or correlation. So You know that marks is nothing to do with height or weight. So, but there may be, a relation between height and weight. Okay, so if height increases, weight increases, but it is not necessary that weight should increase, or we will see whether it is true or not. So we need to do an analytics like this. So what we are going to do here is we'll be using this file, and what I'm going to do here is the same thing. You have to import this pandas module first and read underscore CSV. That is a function for reading from this file called height.csv. So this is my file. And what I have done here is I have printed this data frame and I have called a function called CORR. So this is a built-in function available in Pandas for performing correlation. So it is as simple as that. You need not worry about it. You need not worry about the coding of correlation. But the thing is that you should know statistics. Only then you can identify which all fields are correlated, or is there any meaning in doing this correlation. So I will run this program. So if you look at my screen, you can see, here you can see this, the complete file is printed here, name, height, weight, and marks. And at the same time, you can see a table like output here, like, height and height. Height and height, it is having 1, and height and weight, it is having 0.938. Okay, so if you look at the value here, 0.938, it means it is close to 1. So we can say that there is a very strong positive correlation between height and weight. As I told you, it automatically, when you call this correlation function, it automatically calculates the correlation for all the numeric fields available in that file. So for you, it is up to you to decide whether there is any meaning in taking this value. So you cannot say that if you are taller, you will be scoring more marks. So I'm just ignoring this. So there comes the knowledge of a statistician. There comes the importance of statistical knowledge. So I'll be focusing only this subset, height and weight. So you can see the same value here. If you take weight and height also, or height and weight also, this value will be the same. So that is 0.938, which is very strongly positively correlated. So this is how you perform correlation if your data is structured. The thing is that the data should be structured wherever your data lies, whether it is in a DBMS or what type of DBMS, doesn't matter. It should be imported to a CSV file. And from that point onwards, we will be getting into the environment of data science. And we will be calling this correlation. First of all, we'll be fetching it to this data frame. And that is what is shown here. And after that, you will be applying this correlation function. So this is as simple as that. The only thing is that you have to learn correlation. Rest is very simple. Even a second standard student can do that. If you know the spelling of CORR, he can do this. Again, we will move on to the data visualization part. So this data visualization is really very, very important. As far as, data science or data analytics is concerned, there will be a lot of data in your DBMS or CSV file, but a person can understand it very well when you present it in the form of charts and graphs. So data visualization is very, very important. You might have drawn a lot of charts using Excel. It is possible, but when it comes to the coding side, sometimes your data may be residing in DBMS. You need to do a lot of pre-processing there, and after that you will be fetching it to the CSV file. So you have to imagine like that. We'll be fetching to that CSV file, and from there you will be trying to plot this chart. So we will see the simplest bar chart, that is the vertical bar chart. How to visualize data using a vertical bar chart in Python. Okay. So I will close this window also. So I will open. Okay, bar chart. So for doing the plotting, we need to import one more module like matplotlib.pyplot. So all these are built-in modules in Python. Okay. So I will say, what for about whatever thing you think, a module will be there in Python. So it is just like the building blocks which you have used when you are a kid. You have used building blocks to construct a building. You will place it in appropriate positions, and finally you will construct a building. So likewise, a lot of modules are available in Python. You need not write anything from the scratch. Everything is there. So you have to identify the appropriate module. So pandas, I told you, this is for holding this data frame. That data frame resides in pandas. Then matplotlib.pyplot, this is the plotting module. And as I said, the initial step. So I'll be using this input.csv that we have already seen, input.csv file. So this is our input.csv, that is name, salary, starting date, and department. So I'll be using the same file again. uh, you have to keep it in your mind, not all charts can be applied to all data. So again, there comes the knowledge of statistician. You have to identify which chart or which graph is the most appropriate for your data, to present your data. So in this case, what I'm going to do here is I'll be reading from the CSV file, and now it is available in this data frame. And what I'm going to do here is I need only two columns. Okay, so if you look at here, you can see ID, name, salary, start date, and department. 1, 2, 3, 4, 5 columns are there. But what I'm going to do here is I'm using only these two columns, column B and C, that is name and salary, for drawing this bar chart. So what I'm going to, but I need all the rows. I need only these two columns, name and salary, but I need the entire rows. So for that, what I'm going to do here is, there is a function called data.log, from where you can filter out the required columns that you want. So here I have given colon and comma means it will take all the rows. It will take all the rows. And in brackets, I have given name, comma, salary, which means it will pick only the name and salary column. And again, I will be giving a print statement. Okay. So what the second portion I will explain. So I will run this program. Yeah, you can see a graph too here. Okay, so for the time being, I will minimize it. So if you look at this, this is our original data frame. And see, I have filtered like this, name and salary. So it has taken all these 8 rows, starting from 0 to 7. And it has picked only this name and salary. So, and I have, in the second half, I have drawn a bar chart. So bar chart, you can see name on this x-axis and this salary on the y-axis. So the legend and all, you can see, since this is a very simple bar chart, we will go to this complicated bar charts now itself. So looking at this bar chart, it's very easy to compare the salary of these 8 people. So the purpose of bar chart, this is for comparison, right? So if you want to compare some data, we will be using this bar chart. Okay. So I will show you what I have written in my code here. So this is it. So I think you understood this much, how I have selected this only columns which I want, that is name and salary. Yes or no?
Yes, ma'am.
Okay. So what I'm going to do here is I'll be going to draw a vertical bar chart. So this is the function. Oh, this is built-in. So df is my data frame. This is my data frame. df.plot.bar. Since I'm going to plot a bar chart, I'll be giving plot.bar. And I will tell you what this is. For the time being, let it be like this. ROT, rotation angle equal to 0. That is the meaning. I will tell it later. And I have given x equals name, y equals salary. Okay, x equals name and y equals salary means these are the x and y values. Then the title, then I can specify the color of my graph, then the edge color. And finally, don't forget to give this plot.show. Only if you give plot.show, it will be visible. Otherwise, what happens is it will create the bar chart and it will reside in the memory. You cannot see it. So if you want to see it, you have to give plot.show. And once again, I will run the program. And if you look at this, you can see color is green and edge color is red. So we will see. Yeah, see, you can see green bar chart, the edge color is red, and you can see name on the x-axis, salary on the y-axis. Okay, so I will tell you what this rotation equals 0 at this point. So suppose I am removing this. Okay, suppose I am removing this and I am saving this. So I will run this let us see. So look at the diagram and you have to tell me what has happened. Any change for the diagram? Any change? So if you look at the name, it is just like, the puzzles in, earlier when I was a child, there was puzzles like this, can you differentiate or can you point out three differences between these two figures likewise. So this is the difference. If you look at the name, the way it has written, earlier it was written horizontally, but now it is vertically. So for that purpose, if you are not giving anything, it will be giving like this. It will be writing like this. But if you want to make it straight, you can give this rotation equals 0 or rotation angle equals 0, which means it will write the name in horizontal direction. See, now you can see, if you look at the screen, you can see all the names, Rick, Dan, everything, in horizontal direction. So for that purpose, I have used rotation or rotation angle equals 0 or rotation angle of the text. So that is this vertical bar chart is. And there are a lot of things which you can add to legends. I'm not taking it in detail because, as I told you, this is a very short webinar. So normally I do these data science classes maybe for 1 week. So in that case, you can go detail and you can do a lot of statistical tests and all. But here, what I can do is I can give you, some idea about this data science and analytics. So bar chart. And now what we are going to do is we will see how a horizontal bar chart can be drawn. Okay. So in the case of horizontal bar chart, yeah, everything is the same up to this. Okay, you have this matplotlib, then pandas, you'll be reading this input file to this data frame called data. Then what is this? You will be filtering out name and salary, and you will be printing. The only difference is that instead of bar, you will be using df.plot.bar h. So bar h stands for horizontal bar chart. Okay, so we will run the program and we will see. So you can see this is a horizontal bar chart. You can see name here and salary here. The only thing is that the bar is drawn horizontally instead of vertically. So you can decide which one to choose. It's up to you. Doesn't make much difference. Some people prefer this, horizontal bar chart. Some people vertical bar chart. So the only thing is that, it is as simple as that. Just I want to show you one H can create wonders or difference. So you can very easily draw this horizontal bar chart. So I think I am clear up to this point, right?
Yes, ma'am.
Now, people in many industries or organizations, most of the charts will not be as simple as the like this bar chart. Many a times we need to combine one or two or sometimes three or four, five fields to draw grouped bar chart and stacked bar chart. So these two, grouped bar chart and stacked bar chart, are very commonly used, not only in industry, in your academia, research, everywhere we will be using like this. So you might have seen a grouped bar chart, or else, after executing my program, you will understand what a grouped bar chart is. Like, grouped bar chart means one or two or three bars, there'll be more than one bar under one value. Like, it's a comparison. It is for comparison also. So we will see how this grouped bar chart can be drawn. Okay. Yeah. Again, I would like to tell you one thing. As I told you earlier, not all data can be used for representing all graphs. So we need to identify which is the appropriate graph. So for me, I will show you this investment.csv file. I will open and show it to you. Uh, See, you imagine this is a very small file because since this is a webinar, I have taken only very less data. So I will show you how this could be converted to a grouped bar chart. You imagine these are maybe the sales in lakhs of an organization for software, hardware, and services for the last 3 years. Okay. So from the DBMS, I have fetched this data. I have done a lot of pre-processing. I have removed so many things. I have, done a lot of pre-processing or data cleaning task, and finally I arrived at this point, that is arrived at this CSV file, which is ready for plotting a grouped bar chart. So I will say for a data scientist, this is not a challenging task. Once you get a refined data, it's easy to plot. But the challenging part is not that, data will be always dirty or noisy. You need to remove a lot of noises from the real time data. Only then you can plot according to your requirement. So for that purpose, you need coding for eliminating. Maybe you might be removing it at the DBMS side, or sometimes you may be fetching it to this Excel file, and you will be do the coding. You'll be fetching it to data frame again. You will be removing so many fields. You will be inserting so many fields, and you will be again copying it back to a CSV file. So likewise, you will be doing a lot of tasks, and you imagine that this is your final CSV file, which is ready for plotting this group departure. So I told you, you imagine that this is in lakhs, okay, amount in lakhs for software, hardware, and services of an organization for the last 3 years. So let us see how to draw a group departure. Okay, so the name of my file is investment.csv. So what I'm going to do here is I'll be reading from this investment.csv to the data frame. So my data is ready in data frame, and I need to give some index. So before plotting the graph, I told you we need to do some pre-processing. This is one kind of pre-processing, like automatically in data frame it will be coming like 0, 1, 2. I will show you that if you look at the output, you can see if you look here 0, 1, 2, 3, 4, 5, 6, 7, it is an automatically generated value. But if you want to when you draw a graph, it should be meaningful, like 0th year, first year, second year, it may be not that meaningful. We need to convert it to some value. So for that purpose, what I have given is 0 should be 2017, 1 should be 2018, and 2 should be 2019. So it is the data for 19, 18, and 17. So for that purpose, I have renamed the index. So I think this is clear for you. Up to this much, it is clear.
Yes, ma'am.
Now, the task is to draw a grouped bar chart. So I think I will run the program and I will come back to the code. That will be more easy for you. So this is it. See, if you look at this graph, you can see 2017 here, 2018 here, and 2019. And this is, now you understood what a grouped bar chart is. So for 2017, if you look at the legend, automatically the legend is coming. See how easy it is. The red is for software, the green is for hardware, and this blue is for services. So likewise for 2018 and 19 also. And from this you can see almost the hardware is going consistently. But if you look at the services, it has a huge or tremendous increase in 2019. But if you look at the software, it was low here, but again high, and again low to 2009. So likewise, you can do a comparative study among 3 or 4 elements. So here I have taken only 3 elements for 3 years. Likewise, you can take 5 elements for 10 years. So that is the purpose of this grouped bar chart. You might have seen this, but only thing is how to draw this using this Python code. So that is what I have given here. Data.plot.bar. It is bar. Title. You can give the title, and this is the color that you want to give. So since there are only 3, I have given RGB, or you can give whatever you want. The common colors can be specified using single letters. Okay. So let me check with yellow. So if it is yellow, I'm giving like this. And this is X label, Y label, everything, it's only for beautification purpose, nothing to do with, data science, I will say. So let us see, I have changed the bar to yellow instead of blue. So I'm saving this and I will run the code. Okay. So this is how you can give color to your bars. Again, you can do a lot of things. You can give this values on the graph itself. So many things you can do with the same graph. So as I told you before, drawing is only 1 minute task, but before going to this drawing you have to very well understand the behavior of the data and what you're going to represent, and accordingly you have to choose what graph you have to apply. So here I will say this grouped bar chart is a very good tool for representing these three elements for comparison over these 3 years. So that is how I arrived at a decision to draw a grouped vertical bar chart. Now we will see what we can go for next. Okay, so it is stacked bar chart. Again, stacked bar chart is there. Again, what all data you represent using this grouped bar chart can also be represented using stacked bar chart. But the only thing is that stacked bar chart is a little more difficult to understand for a common man. For a common man, grouped bar chart will be easy, but for a statistician or a person from data science background, it is not a big thing. So we will see what a stacked bar chart is. So I am using the same file, this investment.csv, and I will be going for this stacked bar. Stacked bar chart is nothing but each bar will be stacked. You know what a stack is? Stack of plates. So likewise, each bar will be stacked on top of the other. So that is stacked bar chart, and all the things are same. Like I have given this. I have read from the investment.csv file. Then again, I have renamed the index like 2017 for 0, 2018 for 1, and 2019 for 2. And here I'm going for a grouped, uh, a stacked, sorry, for a stacked bar chart. So the thing is, you can give data.plot.bar. This is the function. And the only thing is that you have to give stacked equals true. So when you give stacked equals true, automatically, it will understand that we need to plot a stacked bar chart. Again, I have already told us what is rotation equals 0. In order to come the text in a horizontal line or a horizontal way, I am giving this rotation equals 0. Again, the title of the chart, the next label, Y label, and don't forget to give this plot dot show. So I will run this program. See, this is it. So this is a stacked bar chart. So for 2017, again, if you look at the legend, you can see that this is the software, this hardware, and services. And you can see, if you look at the size of each bar here, each bar means each portion of this bar here, you can see that services is having a bigger size compared to 18 and 19. But if you see, look at the hardware, it is almost having the same size. Again, if you look at the software, slightly it increased in 2018, but again down in 2019. This is okay, but some people prefer this stacked bar chart. No problem. If you are comfortable with this chart, it's okay. Otherwise, you can go with this grouped bar chart. So what I want to tell you is the same data can be represented using grouped bar chart and stacked bar chart. So we will see what is next. So these are the very commonly used visualization tools, I should say. So if you get into data science, all these are very, very important. Okay. So now we will see pie chart. So as everyone know, pie chart, again, you may think what is there with pie chart. But when you go with coding for pie chart, you have to understand some things. Pie chart is usually drawn for showing proportions. Okay, it is used for showing the proportion. So you know what a pie chart is. It's a very commonly used chart. And we will see how to draw uh, a pie chart. Okay. So this is the pie chart. So I am using the same investment.csv, or if you have forgotten that file, yeah, this is this investment.csv. So before drawing a pie chart, again, suppose if your boss has asked you to draw a pie chart or present a pie chart for the last 3 years of software, hardware, and services, anyway, you have to take a sum, right? You need to add all these values in lakhs, all these hardware. Again, you have to take the sum and all the services. Only then, you can decide the proportion, okay, for how much of money or how much of profit you got for last 3 years from each sector, okay, each sector. So that is what I was telling you in the beginning. Depending on your requirement, you have to decide. So we have drawn grouped bar chart, stacked bar chart using the same file, but now I am showing a pie chart from the file, but things are slightly different because as I told you, I need to sum up. I need to sum up all the software profit. I need to sum up all the hardware profit, and I need to sum up all the services profit. So there is a built-in function. Again, what I'm going to do here is, there is this pandas. Then numpy is, sometimes we'll be using numpy for matrices, but actually I have not used here. I have simply written an import here. Again, plot, for plotting. Then here, once it is read to this data frame, now the data frame is ready, and I need to sum up each column values. So what I can do here is data is my data frame. So I'm giving like this, data of software dot sum. Again, data of hardware dot sum. So sum is a built-in function where you can sum up each column. And you can print that and you can see that. So I will run this and I will come back once again. Don't look at the pie chart now. Okay, I will close this window. So up to this much, we will see. Yeah. So this is the data frame. Okay, 0, 1, 2, software, hardware, services. And what I have done is I have summed up this column. Okay, 34, 56, 48. That is this 138. And again, these three, this is 234, and these three, this is 182. So now it is ready for drawing a pie chart. But again, I need to rename. It is 0, 1, 2. Nobody is going to understand what is this 0, what is this 1, and what is this 2. So I need to rename this like software, hardware, and services. So for that, what I have done here is I have again renamed like this. 0 software, 1 hardware, 2 services. Okay, and again, if you look at the output, you can see this is renamed, and again this 0 is renamed to total. Okay, so this is important while drawing this graph. So maximum data cleaning process should be should be done here. Otherwise, when a graph is drawn, you will get the graph, but nobody is going to understand what the 0 is, what this 1 is. So before that, you have to do all this data cleaning and the data pre-processing tasks. So that is what I have done here. 0 is replaced with software. Then 1 is replaced with hardware, and 2 with services. Again, the 0 is replaced with total. So that code you can see here. So I have renamed the index like this. Again, I have renamed the columns, the 0th column to total. So that is, after that, I have given a print statement. That is what you have seen on the screen. And now coming to pie chart has a lot of parameters, lot of attributes here. And you have to pass the y value. You have to pass the y value in the sense what you are going to pass, because you may be passing a single column to a pie chart. Okay, so here I'll be giving total. So here what you are going to do here is this value. Okay, this value will be passed, because depending on this value, the pie chart will be drawn. And this is the title. Then I have given auto PCT. So auto PCT is, normally you can see pie charts coming as percentages, right? So you look at the last percentage. Okay, so I should say you might have seen these type of formatting in format specifies in C programming, right? So likewise, it's a kind of formatting. So this last percentage is to display the percentage as such, and you have a percentage on the left, and here a percentage after f. 1.1 f means, it will display one value after the decimal. So that is the meaning. So that is this auto PCT. Then if you look at, I have given 0.1. So I have given the third item, that is services. So this is my third item, to explode. Explode means it will move away from the center. So for that purpose, and these two will be connected, I mean joined together. So if you want to show everything is joined, you simply give 0. Or if you give 0.1, what happens is hardware and services both will be exploded. So it is up to you. Then shadow is true if you want to give a shadow effect. And start angle is 0. That's very important. Start angle. I will tell you what start angle is. So you look at this figure. Okay. So look at this figure, software, hardware, and services. Okay, and you can see after decimal, you can see this percentages come. And I will tell you, if you are a Java programmer, if you have worked with applets, the start angle starts at 3 o'clock. So if it is a clock, imagine a clock, start angle equals 0 will be at 3 o'clock. Okay. And it moves in the counterclockwise direction. It moves in the counterclockwise direction. So here it will be 90. So likewise, in the case of drawing a pie chart, it will start from 0 and it will be moving like this. Okay. So don't think that, it has drawn in a random way. No, it is not like that. It has an order. It has started because software is our first value. So it started from 3 o'clock. Then in the counterclockwise direction, it has drawn this. So I will show you, I will change the code and I will show you. And again, one more thing, if you look at only services is exploded, right? So I will change like this just to show you. I'm giving hardware also exploded. So let us see. Now you can see, because there are only 3 items, if hardware is exploded, then the software looks like exploded, but actually I have given this 0.1 only for this hardware and software, so hardware and services. Again, I'm changing the start angle. As I told you, start angle is at 3 o'clock, and now I'm giving start angle to 90. So, as I told you, it moves in counterclockwise. So when I give start angle equals 90, it should start from 12 o'clock. So let us see whether it draws like that. See, now look at the software where it is. It starts from 12 o'clock. It moves in counterclockwise, and then hardware, and then services. So this is how we draw a pie chart. There are a lot of things which can be added to a pie chart. I'm not going into the detail. So I think you got some idea. You got at least a little idea about how to plot a pie chart from a CSV file. So we have raw data with us. We have done a lot of data processing, pre-processing tasks, and finally we have drawn a pie chart. So I think I'm clear at this point, right?
Yes, miss.
Yes. And one more important data visualization tool I would like to introduce you is the box plot. I don't know how many of you have used box plot. Have you ever used this box plot? Just for my information. No.
No, miss.
Yes or no? No problem. If you have not used, no problem. Why I am introducing this box plot is because you know what a group bar chart, what a pie chart, or what a bar chart is. But most of the time, statisticians will be, or when you work with data science, people will be using box plot. I will say this is the heart of any visualization. You cannot skip this box plot. So actually, box plot means the full name is, it's a box and whisker plot. If you look at this figure, you can see there are 2 whiskers towards left and right. Okay, so this box and whisker plot, it is in short form it is called as box plot. It displays the 5-number summary for a set of data. So if you have a set of data, it will display, when you draw this box plot, it will display the 5-number summary. And this, we will see what all are these 5-number summary. It is the minimum value, then the first quartile, then the median, then the third quartile, and the maximum value in that data set. So this is very, very important as far as a statistician or a data science person is concerned. So looking at this data, looking at this box plot, he can arrive at a lot of conclusions, whether most of the data is lying above the median or most of the data is lying below the median, or whether there is huge difference between min and max, then where is the first quartile. So if you can see, again, you can see if this minimum and maximum, if it is having a higher range, you can think of eliminating this minimum and maximum values. So when we come to research and outliers, it creates a lot of problem to researchers. We need to eliminate it. So if you draw a box plot, everything will be clear to you, instead of going through each data line by line. This graph or this plot clearly represents your data. So what all things, as I told you, these are the two whiskers, and you imagine that this is your data. So from this plot you can see this is minimum value, quartile 1, median, quartile 3, third quartile, because second quartile is called median, and the maximum value. Okay. Now I will show you a box plot illustration, how you could draw box plot by hand. Means, and after that I will show you how it could be generated using this Python code. Because only if you understand how it could be drawn by hand, then you will understand the relevance. For what purpose this box plot is used. So I will explain it with a very simple example. You imagine that you have a sample of 10 boxes of raisins, has these weights in grams. You have 10 boxes here, and each box is having different weight. Okay, it contains raisins and it is having different weight. And suppose if you want to make a box plot of this data, the first step what we are going to do is we will order the data from smallest to largest. You imagine that we are going to do it by hand. So in this case our data is already in the order, right? And the second step is to find the median. So median, it is the middle of two numbers. So if you look here, 30 and 34 are the middlemost values, and so we will take the median as 32. Again, we need to find the quartiles. Okay. So finding the quartiles, you might have learned this. I don't know. I'm not sure whether you have learned this. For taking the first quartile, what we are taking is we will take all the data points to the left of the median. So since it is 30, if you look at the data, since it is 30, we will take all data to the left of the median. And for third quartile, we will take all data to the right of this median. So here, the data to this left of this median is 25, 28, 29, 29, and 30. And again, we will take the median of these. So here, looking at the data, you can see the median is 29. So that is termed as first quartile. And again, in a similar way, we will be taking the third quartile, like, 34, 35, 35, 37, 38. And again, the middlemost value is 35. So now, again, which is the smallest value and which is the highest value, because we have arranged the data. See, looking at the data itself, since this is a very small set of data, you can very well understand this is the smallest value and this is the largest value. So when I say all these things, you have to visualize when you work with lakhs of records or hundreds of records or thousands of records. It is not easy to identify like this. So at that point, we'll be using it tool like this, but behind the curtain, you have to understand what is happening. So that is why I am trying to, explain this box plot. So now everything is ready. I should say the minimum value, the maximum value, the median, the first quartile, and the third quartile. Okay. And what you can do next is, you can make a box plot. So what you will do is you will draw all these, 25, 28. I have not written all here, 25, 26, 27, 28. Okay. Then 29, 30, 31. Likewise, I have written only a few numbers here, but starting from 25 up to 40, I have marked. Okay. And the next step is we will identify our median. So our median is, what was our median? It is 32, right? So median is 32. So I will draw a straight line here. And I will identify the first quartile and I will identify the third quartile. And I will join this as a box. So now median, my first quartile, and third quartile is ready. And after that, I will draw two whiskers to the left to reach the minimum value and to the right. So right is 35. So here, this is the maximum value. So up to this much, I will be extending this whisker. Okay. So towards left, you can see it is 25. But if you look at this data, there is not much difference, not much variance here. You can see almost, if you look at the median, you can see that data is almost equal to the left and right. And there is no outlier. Suppose if your maximum value was 120, 125, then this whisker will be extended. And looking at the figure, you can see that, there is a great variation between the lowest value or the minimum value and the maximum value. And if there are more values towards the right, this box will be huge compared to this side. So likewise, you can understand how much of data is residing to right and how much of data to the left. Or if you can see, if this rectangle is big, you can say that most of the data lies above the median. And suppose if this was big, you can say that most of the data below lie the median. So, but in our case, it is almost equal. That is why it came in the center position. Okay, so this finally it looks like this. So I think you understood how a box plot can be done. Yes or no?
Yes, ma'am.
Yeah. So now we will see how to draw this using a Python code. Okay. So as far as Python is concerned, it will be very simple. Again, as I told you, I am going to use another file because marks, I need to draw box plot for marks, and I will be using a file called marks2.csv. I will show you what it is. You imagine that, these are the names of students and these are the marks for 3 subjects. And this is biology, maths, and physics. Suppose if I want to, I can draw box plot for individual subjects. At the same time, I can draw box plot for these multiple subjects. So let us see how it could be done. So as I told you, you can read from the CSV file, and when you print the data, it will be ready in a data frame. And suppose if you want to take the box plot of biology, you extract that particular column like this, data of biology, and you give df.plot.box. Box is a function for drawing box plot. So you can draw this, box plot for biology. So the purpose is that, I want to find the middle value for biology, the marks for biology. And I can, for a teacher, she can very well understand how many students is, or whether I can reach a conclusion that whether most of the students is below that average mark or it is above the average mark. So that purpose, this box plot is used. In a similar way, you can select 2 columns. If you want to draw for 2 columns, you can select like this, biology and physics. Or you can draw for all subjects. That is for multiple box plots. You simply give data.plot.box. And you can give X label and Y label as required. Okay. So I will save this and I will run the program. Yeah, I will show you one by one because there are 3 plots here. See, this is the first plot. Okay, for biology, if you look at this, you can see that, most of the students in this class are very poor in biology because see, the size of the rectangle here, this is the median. This green line is the median. Only a very few has got, more than this average marks or the median marks. So most of them are poor at biology. So that is the conclusion from this picture. Again, you can have a comparison between biology and physics. Suppose if you want to have a comparison like this. Here, it is almost the same, students, good and bad or above average and below average are almost the same. But if you look at the whole class average, the class average is slightly higher than biology. Physics, it is slightly higher than biology. So that is the understanding of this plot. I think it is clear. Yes or no?
Yes, ma'am.
Yeah, thank you. Now, if you look at this, this third one, maths, the problem is median is here, but it has not even tried to draw a whisker because there is a great difference between the lower value and the higher value. So it has not, or if you look at this value, actual value, you can see here. Because see, if you look at the value 89, 80, 78 and 89, all it is very close, and this 45 is far away compared to the other 4 values. So that is why it has plotted this graph like this. So likewise, you can have box plots for your numeric values. And I think now you understood the importance of box plot. It is very, very important, not only for comparing these marks, as far as industry is concerned, or academia or research, whatever. This box plot is very, very important. And I should say this is the most commonly used, frequently used, and most, sought after chart used by statisticians. So I think our time is over. So anyway, thank you so much for your listening and for a response to. Once again, I thank you, all the coordinators, all the participants, for listening to me patiently. Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. That was quite informative. Now, I would request anyone, any of the participants, if they have any questions, they can ask.
Good morning, ma'am. I
Good morning.
just want to ask, which is better, Python or web development?
Oh, that is, I should say, it's like, which is good. You are asking such a question like, which is good, your left hand or right hand. So, if you are interested in web development, you can go with web development. There is a Python Django framework. There are so many frameworks for Python, like, Bottle, Flask, Pyramid, then Django. So many frameworks are available for web development. Again, if you are a data scientist who are very much interested in analysis and statistics, then you can go with data science. I should say Python is just a tool only. The thing is that you have to learn the things behind it. What I told you in the beginning, if you want to be a good data scientist, you should be a good statistician. So that is the thing. So if you're not at all interested in statistics, don't go that way. You can choose web development. No problem, because both are two different things. Like, they are two different doctors, like a dermatologist and a gynecologist. Nothing in common. If you're interested in that particular subject, you can take that. That's it. That is my answer.
Okay, ma'am. Thanks so much.
Good morning, ma'am.
Good morning.
Is Django important for data science?
No, not at all. It's a framework for developing website application. As far as Python is concerned, Pandas, Matplotlib, NumPy, all these are modules related with data science. That is what I want to tell you. Like, sometimes you imagine I will use the same example. Like, you imagine a cardiologist. You assume that you are a web developer. He's like a cardiologist. You will be very much expert in that field. But if you are asked to do a cesarean surgery, you could not do that, even though you are a doctor. See, that is the situation. You may be an expert in web development, but it has nothing to do with data science. So if you want to be a data scientist again, that's totally a different subject. Totally a different subject. Web development is different. Django has nothing to do with data science. But you can club these two if you want. You'll be developing a website. In that, you can incorporate data science. But that time you have to use again Pandas, Matplotlib, and NumPy. That is it.
Okay, thank you, ma'am.
Good morning, ma'am. Ma'am, can you say the future of data science and Python? I mean, what's the future of data science and Python?
Future in the sense is, nobody can predict in which direction we are going, because I will say, if you are asking me about the future, I will talk about internet of things, because um, today I have just given a drop of water. Actually, it is an ocean. So here, you will be in this data science. We will be storing the data in a DBMS. We'll be fetching to a CSV file, and you will be doing the analytics. But in future, it may not be like that. The data will be sensed. Now itself, it is like that. It will be sensed from sensors, and it will be stored in the cloud, or we will be going for the edge computing or fog computing, and we will be doing the analytics in cloud itself. And at the same, everything will be doing dynamically. Everything will be doing dynamically, and it will be giving feedback at the same time, and accordingly you will be not you, the machines will be acting. Or I would like to say, rather, the machines will be talking each other, rather than human beings. So that will be the future. And I I don't know, I really worry, where we are going, because once the technology take the place of human beings, I will say we are in some danger, I should say, because machines don't know this emotional don't have this emotional intelligence. So that is again another issue, another big topic to be discussed. But anyway, it will smoothen our life, it will make our life easier. So likewise, we'll move forward.
Okay, ma'am. Thank you.
Thank you, ma'am. It was quite informative and we have learned a lot from this webinar. Now I request all the participants to please fill the feedback form, the link to which is in the in the chat box. And now I invite the Assistant Professor Arya Lakshmi Miss for the vote of thanks.
Good morning to one and all. It's my privilege to express our sincere gratitude to each and everyone present here on this occasion. On the behalf of entire Department of Computer Application of SRBS Gujarati College. First of all, I would like to thank our resource person, Dr. Jeeva Jose, who have spent her valuable time and effort for us. Thank you for having given us an idea on a current trending topic, data science using Python. Next, I would like to convey my gratitude to the President of Sri Cochin Gujarati Mahajan Kishore Sir. Then the Educational Board Advisor, our beloved Professor Avi Kilkar Sir. Thank you, sir. I also have a grateful to our manager, Bharat Sir, and all the other board members. Next, I thank our dearest principal, Dr. K. Prasanna ma'am, for all her support and guidance. And a special thanks for Dr. Leena Srishekar, MES College, Marambali, for her extreme presence. I convey my sincere gratitude to all my research scholars, teachers, and other dignitaries, our students, friends, and all who present here. Thank you one and all. This vote of thanks would be largely incomplete without expressing our gratitude to all our colleagues and students who been working really hard for this webinar. I sincerely apologize if I miss out anyone. Thank you once again being here and spending your valuable time with us. Good day to everyone.
We are winding up the session. Thank you. You will be getting e-certificates.
We are now winding up this session. All the participants will be provided an e-certificate. So thank you for being with us today.